दोस्तों, आज की इस वीडियो में हम न्यूक्लियोफिलिक सब्स्टिट्यूशन एट एन एलाइलिक कार्बन बताएंगे। तो आप लिख भी सकते हैं कि न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन आर इन्वॉल्व इन डायरेक्ट डिस्प्लेसमेंट एट ए कार्बन सेंटर। द कार्बन दैट इज बॉन्डेड डायरेक्टली टू द लिविंग ग्रुप इज द टारगेट फॉर द attacking nucleophile. This process also known as SN2 substitution. Generally, primary alkyl halide undergo substitution by the SN2 mechanism and do not undergo SN1 reaction. However, a primary allyl halide is very reactive in an SN1 reaction. For example, allyl halides are more than 30 times reactive than an ethyl halide. Allylic substrates are usually accompanied by a reagent known as allylic reagent. In an SN1 mechanism, the carbocation intermediate would have two possible resonance forms, and this is likely in cases when the allyl compound is unhindered and a strong nucleophile is used, and the product will be similar to those seen with SN1 substitution. Thus, reaction of 1-halo-2-butene system with nucleophile NOH gives a mixture of 2-butene 1-ol and 1-butene 3-ol. आप इस रिएक्शंस को देखें, ये जो 2 पोजीशन है वो एलाइलिक कार्बन कहलाता है। एलाइलिक कार्बन पर जो हैलोजन है वह एलाइलिक हैलाइड कहलाता है, जो लिविंग ग्रुप। जब ये लिविंग ग्रुप लीव करता है तो ये कार्बोकटायन का फॉर्मेशन करता है। अब इस पर न्यूक्लियोफाइल अटैक होकर एक प्रोडक्ट ये बन सकता है, और ये डबल बॉन्ड अगर इधर शिफ्ट हो गया तो पॉजिटिव साइड की पोजीशन 4th हो जाती है और ये रीअरेंज प्रोडक्ट न्यूक्लियोफाइल बी प्रोडक्ट बनता है। तो फ्रेंड, the incoming nucleophile therefore would attack either C2, the carbon originally bonded to the living group, or alternatively at carbon 4, and these two events would lead to 2 different substitution products B and A respectively. Friend, you can see the another examples here, the product nucleophile and B the product of nucleophile. So the mechanism leading to the product A are referred to as nucleophilic allylic substitution. They are also sometimes referred to as 1,4 substitution according to a numbering system where the living group is designated atom. If the conjugated pi electron orbital system extends further, more allylic substitution product can result. In the following example, 1,6 as well as 1,4, 1,2 substitution are possible. So ये आप देखें कि लिविंग ग्रुप जिस कार्बन पर है वो 2 है, तो इलेक्ट्रोफिलिक कार्बन जो है वो 2, 4 और 6 दोनों हो सकते हैं। एग्जाम्पल में अगर ये लें तो अगर Cl निकलता है तो CH2 प्लस होगा, तो CH2 प्लस होगा तो न्यूक्लियोफाइल यहाँ आ सकता है, या ये CH प्लस पर यहाँ आ सकता है। So for 2 distinct mechanism for aliphatic nucleophilic substitution SN1, SN2. In its term of stereochemistry, the SN2 process is attended with inversion of configuration, where substitution occurs at a chiral carbon. In SN1 mechanism involve inversion and retention of configuration, decimization. The question is that is whether there are cases where is the retention of configuration in SN reaction. The answer is yes. Beside NGP in SN reactions, there is another important mechanism labeled as SNI. तो allylic system में आप देखें कि the position adjacent to the carbon double bond often show enhanced reactivity compared to simple alkane due to proximity of adjacent p orbital system. Such positions are referred as allylic. Recall that the term vinylic and is used to describe the atom directly associated with the carbon-carbon double bond unit. So ये देखें आप resonating structure plus half of this system. Thus, in allylic system, carbon 1 and 3 each carry a partial positive charge, and both were attached by a nucleophile, which lead to the formations of the two products. The resonance stabilization of allylic carbocation is presented as above in the orbital picture. The positive charge is delocalized over two carbon atom by overlap of the filled p orbital of the pi bond with the vacant p orbital of the carbocation. Nucleophilic substitution at an allylic carbon can also take place by SN2 mechanism, in which no allylic rearrangement usually takes place. However, allylic rearrangement can also take place under SN2 condition through the following mechanism, in which the nucleophile attack at the gamma carbon rather than the usual position, and this mechanism is called SN2 prime mechanisms, and the SN2 prime mechanism normally occurs exclusively when SN2 process is sterically hindered. तो आप ये देखिए कि एलाइलिक पोजीशंस पर X ग्रुप लगे हुए हैं, ये अगर जाता है तो ये वाली प्रोडक्ट बन जाती है, Y यहाँ पर इस पोजीशन पर है. So thus p orbital system of the double bond can stabilize an adjacent carbocation by donating electron density through resonance. Due to the stability of these allylic cation, they are readily formed as intermediate during the chemical reaction. For example, SN1 reactions of the allylic halide. अब ये देखें कि allylic chloride, bromide and iodide are good substrate for the substitution reaction. A variety of nucleophiles can be used to generate a range of new functional groups. The process can be completed by the allylic rearrangement, where the nucleophile can attack either of the deficient site.